reduce fractions, or let's simplify fractions. Let's write them in reduced form so that they're as simplified as possible. And we're going to use slope here to motivate this idea, just to make it make a little more sense and be a little more concrete. So if someone asks you reduce 3/9, that's, in a slope context, that's like up 3, right 9. Okay, terrific. Well, what we want to do is we want to see, is there any number that goes into 3 as well as 9? That would be in the non-geometric context. And if we can find a number that 3 and 9 share, can we find the biggest number that 3 and 9 share? Can we find the greatest common factor? So that we can reduce that out of the numerator and the denominator and write it as simply as possible. So 3 and 9, how do you make 3? Well, 1 times 3, so the factors are 1 and 3. How do you make 9? So that's 1 and 3. How do you make 9? That's 1 times 9, or 3 times 3. So they both share a 3 in common. The numerator and the denominator are both multiples of 3. That's their greatest common factor. So now what we're allowed to do is, essentially, we can just cancel out the 3 over 3. Now you might ask yourself, why? Well, 3 divided by 3, if you ask yourself what that is, if you have 3 children and you divide up 3 lollipops, each child gets 1. 3 divided by 3 is 1, and 1 times 1/3 is just 1/3. And you ask yourself, just to be sure, is there any number other than 1 that's a common factor between 1 and 3? There is not. So you have reduced this. You have simplified these fractions. You have reduced these fractions completely. You have simplified the fractions as much as possible. Now, in the geometric context, instead of slope-wise, instead of going up 3 right 9, we have found the slope, the reduced slope, to be 1/3. That's like going up 1 right 3. See it again, up 1 right 3. Perfectly hits on the line, up 1 right 3. So that's a way to show that you're correct. And notice how we sort of drew that staircase 3 times. That was what we reduced the numerator and the denominator by. So 3/9 reduced as much as possible is 1/3. All right, let's try another one, shall we? So 10 halves, or 10 divided by 2. Well, so you ask yourself, what is the greatest common factor? What's the biggest number that goes into 10 and 2? Well, the only way to make 2 is 1 and 2. We're going to disregard 1 because 1 goes into everything. So does 2 go into the numerator? Well, 5 times 2 is 10, and 1 times 2 is 2. I like to stack the common factors right above each other. You don't have to do that. But again, recall 2 divided by 2 is 1. And 1 times 5 over 1 is 5 over 1. But if you're on something like delta math, or you just really want to do this perfectly, you should simplify this to the number 5. 5 divided by 1 is in fact 5. But if you think of that as in a slope context, rise over run, we're rising 10 and running 2. Let's just verify that we're correct here with our reduced fraction. That's like going rising 5, 1, 2, 3, 4, 5, right 5. I'm sorry, up 5, right 1. And we try that again, up 5, right 1. So you can see we made the staircase twice. We reduced numerator and denominator by the greatest common factor of 2, and our final answer is 5. This is a slope of 5, or 10 divided by 2. That fraction reduced completely is just whole number 5. All right, so now we got another one here. Now notice there's a negative. To be clear, there is one negative. You could put the negative, you could put it up top, you could put it down low, or lots of times you'll see that teachers will just sort of put it right in line with the fraction bar. However you write it, there's just one negative sign. There's like one toothpick, if you will. So you're asking yourself, you have 3 and 15. This is a fraction. You're going to try to simplify it as much as possible. What's the biggest number that goes into 3 and 15? That is 3. Now keep in mind, I like to put the negative up top. We have negative 3. You could say it's times 1. 15 is 3 times 5. Now, it's okay if you write it as 5 times 3. The order doesn't really matter. You just have to know that 3 divided by 3 is 1, And then just do some careful record keeping. There's a -1 up top and a 5 down low. -3/15, the fraction reduced, is -1/5. And so we can always check it graphically. Down 1, right. 1, 2, 3, 4, 5. Do it again. Down 1, right. 1, 2, 3, 4, 5. Do it again. Down 1, right. 1, 2, 3, 4, 5. So it perfectly lands on our line. So we have, we still have the equivalent slope. We have the equivalent fraction. We've just reduced it as much as possible. We found that greatest common factor. So a lot of these examples, just to kick it off, the greatest common factor is 3. That's the case here as well. 3 times 1 and 3 times 4. So the numerator and denominator, the biggest number they share in common, they're both multiples of 3. So we can cancel that out. Recall 3 divided by 3 is 1. So we've got a quarter. That's our final answer. That's our reduced slope. And up 1, right 4, up 1, right 4, up 1, right 4. We reduced the staircase. We were able to draw 3 of them. And that was the greatest common factor in the numerator and denominator. So we got another fraction here. We got -4/16. How can we reduce this? Well, 2 goes into both. So that'd be a good start. Now that's a common factor. 4 and 16 are both multiples of 2. But we can go further. We could divide by 2 again. Or if we were trying to find the greatest common factor right out of the gate, we could divide numerator and denominator by 4. But so here we'll just say, is this small enough? Is this reduced completely? Well, we could divide by 2 again. That's -1. Divide by 2. That's 4. So you could just jump right to there by dividing the numerator by 4 and the denominator by 4. And notice how I did not lose the negative sign. And, I just keep showing the slope argument. Down 1, right 4, down 1, right 4, down 1, right 4, down 1, right 4. That's perfect. Now, let's say you're given a fraction, something like -4 over -6. Well, here we have 2 negatives. So they both are multiples of a negative. That's interesting. 4 is 1 times 4, 2 times 2. 6 is 1 times 6, or 2 times 3. Ooh, they share a 2 in common. 2 is the biggest number that goes into both. Or really, they both share a -2 in common. -2 times 2 is -4. -2 times 3 is -6. Recall, anything divided by itself, -2 divided by -2 is 1. What's left over? We've got 2/3. And if you were thinking of this from a slope context, let's just pick a point here. If you were going down 4 and left 6, that's left 1, 2, 3, 4, 5, 6. Look, that is a great compelling argument to show you that a negative divided by a negative is a positive. This line from left to right increases. It has positive slope, and we can double check that we're correct. Up 2, right 3, boom. Again, up 2, right 3. So we do have the equivalent fraction, and we got rid of the double negative. Also, conceptually, I think of it as if I have the two toothpicks. In the numerator and denominator, you could sort of stack the toothpicks up to make a plus sign. This slope is, in fact, positive. So I hope these examples helped you simplify or reduce fractions a bit more, and help provide some context for it with a slope sense. Thank you.